So what are progressions? What are progressions? So if you see the word progress here, okay. So by progressions, we mean that we are having a particular sequence of numbers which is progressing in a certain way. Progressing in a certain way. So there is a pattern involved. Okay. So that is what is meant by progressions literally. So in our course, we will be dealing with three kinds of progressions. The first will be arithmetic progressions. Most of you must have heard about them. If not, there is nothing to worry. We will be starting from scratch. So they are known as AP in short. The second ones are geometric progressions. Geometric progressions are known as GP in short. And the third one are harmonic progressions, which are known as HP in short. So what is a progression? Progression is a pattern of numbers which are progressing in a certain way. So when I talk about progression, I mean to say numbering is fixed. First, second, third, fourth, and so on. First place, second place, third place, fourth place, and so on. So every number will be given a place. And at every place, something similar is going to happen. Okay. So we will observe what happens in these kind of progressions. Okay. So let us start with an arithmetic progression. AP. So as we all know, when we go to school, we start counting. So we start counting from 1. Okay, so how do we count? So we write the first number as 1. Then the second is 2. Then the third is 3. Then the fourth is 4, and so on. So what is happening? If I call this as the first place, so A1, the term at the first place, this is A2. The term at the second place, this is A3. The term at the third place, this is A4. The term at the fourth place. So basically what I'm saying, I am giving a place to each of these terms. That means the place is fixed. The place cannot be changed. So what is happening? When I'm going from A1 to A2, I'm adding 1 to A1. When I'm going from A2 to A3, I'm adding 1. When I'm going from A3 to A4, I'm adding 1. So what kind of progression is this? This is a progression where the first term is 1 and there is something known as D. D is 1. And what is D? Common difference. Now, what is common difference? Common difference is denoted as AN minus 1. That is current term minus previous term. So any kind or any sequence or progression which is following this pattern where we are increasing or decreasing by the same number every time, that kind of progression is known as arithmetic progression. Now, it can be negative also. For example, let's do back counting. So when we are small kids, so we are told, okay, back counting. So now 100, 99, 98, 97, and so on. So suppose your first term is 100, then you go to 99, then you go to 98, and so on. So here your A1 is 100, your A2 is 99, your A3 is 98. So what is happening? Minus 1. Okay. So the common difference can be positive, can be negative. It is not necessary that the common difference has to be positive only. It can be positive, it can be negative. Okay. If the common difference is 0, then it is actually a redundant case. There is no need to discuss it. Okay. For example, if the common difference is 0, so you have something like this, 1, 1, 1. So there's nothing interesting about this progression. So When we talk about arithmetic progressions, we are talking about a first term. Then there is a difference, common difference. So either we are increasing by a particular number or we are decreasing by a particular number. So that is the concept of an arithmetic progression. So let us formalize it. So if an, we write it like this. If an is an arithmetic progression, then a1 is called the first term. Okay. D is called the common difference. So you can note that A1 will be A1. For example, you call A1 as A. Then A2 will be A1 plus D, which is A plus D. A3 will be A plus 2D. So this way, the term at the nth place will be A plus n minus 1D. So this is the formula. This is the formula for nth term of an arithmetic progression. So how do we calculate the nth term of an arithmetic progression? Take the first term plus n minus 1 times d, where t is a common difference. So now this is the formula for the nth term of an arithmetic progression. We need one more formula. Suppose you are given a1, a2 till an. Okay. So you are given first n terms of an arithmetic progression. So when you are given first n terms of an arithmetic progression, so what is Sn? Sn is a1 plus a2 till an. And how do we define Sn? Sn is the sum of first n terms. Please note that first is very, very important here. If I say S50, it means I'm adding the first 50 terms of an arithmetic progression. We have to start counting from the first number, the first term of the arithmetic progression. Okay, so let's try to derive a formula. So Sn is A1, we can write as A, A2 is A plus D, then we will have A3, which is A plus 2D, and we will be going till A plus n minus 1D. Okay, so how many times are we counting A? We are counting A n times because there are n terms and every time A is coming. So we will have n times A, and then we take D common and we have 1 plus 2 till n minus 1. Okay, so this is an plus d. Now this is the sum of first n minus 1 natural numbers. Okay, if you know this, please remember that whenever we are adding first k natural numbers, the sum is k into k plus 1 by 2. If you know this, well and good. If you do not know this, please note it down. Sum of first k natural numbers. So now we have the sum of first n minus 1 natural numbers. So we should be n minus 1 plus 1 divided by 2. So we have a n plus d by 2. And then this is going to be n minus 1 into n. So n minus 1. So let's take n by 2 common. We will have 2a plus n minus 1d. So what is the sum of first n terms of an arithmetic progression? N by 2, 2 times first term plus n minus 1, the common difference. This is also a very, very important formula. Also, if you want to observe, you can see that this is nothing but n by 2 a plus n minus 1d. I have split this a as a plus a. Okay. So this is your first term and this is your nth term. So whenever you are calculating the sum of first n terms of an arithmetic progression, it is n by 2 multiplied by the first term plus the nth term. Okay. So either you can use this or you can use this accordingly as the demand of the question. Okay. So this is all about arithmetic progressions which we should know to solve questions. So what happens in a geometric progression? So in a geometric progression, what is happening is this. The first term is A, okay? The second term is A multiplied by R. The third term is A multiplied by R square. The fourth is A multiplied by R cube. So what is happening? I am multiplying to go from first to second term, I am multiplying by R. Then again to go from second to third term, I am multiplying by R. Then again from going from third to fourth term, I am multiplying by R. So in the case of arithmetic progressions, we were adding by a particular number. But in the case of geometric progressions, we multiply by a particular number. Okay. So again here A is the first term and R is called common ratio. For example, you take this 1, 2, 4, 8, 16 and so on. आप notice करिए. This is 2. Where I multiply 1 by 2, I get 2. When I multiply 2 by 2, I get 4. When I multiply 4 by 2, I get 8. When I multiply 8 by 2, I get 16. So at every step, I am multiplying by a particular number. So what should happen here? The nth term divided by the n minus 1th term. That means the current term divided by the previous term should be equal to R. And what is this R? This is known as common ratio. Okay. So this common ratio can be more than 1. This common ratio can be less than 1. This can be positive. This can be negative. If it is 1, again, it will get A, and so on. So there is no need to discuss it. If it is 0, I'll get A, comma, 0, comma, 0, comma, 0. So no need to discuss it. So generally, we are more interested in when R is greater than 1 and when R is less than 1. Okay. So that is the definition of a geometric progression. Now, if I want to give it a pattern, like in the case of arithmetic progression, what is that pattern? So the first term, suppose an is the nth term. Okay. So you can note that a1 is I am taking as a. Then a2 is a r power 1. Okay. a1 is a r power 0. Anything raised to the power 0 is 1. Note that I will not be taking r equals to 0. Okay, because 0 raised to the power 0 is not defined. Then if we take A3, A3 is AR square, which is AR 3 minus 1. So whatever is here, I am subtracting 1. So what is the formula for the nth term? First term, common ratio raised to the power n minus 1. So this is the formula for the general term of a geometric progression. किसी भी geometric progression की general term निकालने का formula है an equals to a multiplied by r raised to the power n minus 1. Now this is very, very important. Okay. So likewise, we have the sum of first n terms of a GP where r is not equals to 1 and r is not equals to 0. Okay, because these are redundant cases. So we are not discussing for these two numbers. It makes no sense. Okay, so what does it mean? Sn equals to a1 plus a2 plus a3 till an. Okay. So Sn would be, what is A1? A. What is A2? AR. What is A3? AR square. And what is An? AR n minus 1. Please pay attention. The derivation is not important, but see what is happening. So Sn is this. Now we can take A common from each term because each term is having A. So this is A 1 plus R square till Rn minus 1. Okay. And this particular expression can be written down as Rn minus 1 upon R minus 1. Okay. Now, to go from here to here, you should know, like, I'll just give you an example. For example, I divide R cube minus 1 by R minus. Okay. Let me just give you an example. So then I am dividing R cube minus 1 with R minus 1. So R into R square is R cube. R square into minus 1, R square. Subtract. This is known as long division. So minus R square minus 1. Then R into, so this is minus R square. This will become plus. Okay. So then R into R will be R square. Then R into minus 1 will be minus R. Then again change the signs. We'll get R minus 1. Then this will be plus 1. R into 1 will be R. 1 into minus 1 will be minus 1. Subtract, you get 0. So when I am dividing R cube minus 1 by R minus 1, what I am getting? R square plus R plus 1. So this is a pattern. So we had a power 3 here. So we'll start with power 2, then power 1, then 1. So we had power n here. Okay. So we will start with Rn minus 1 and then we'll go till 1. So this is just an illustration of how this thing is obtained. There is no need to learn how this thing is obtained, but you can remember this formula, but learn the formula correctly. Okay. So this is the formula for the sum of first n terms of a geometric progression. Okay. So then we have one more formula. So we know that Sn is equal to A Rn minus 1 upon R minus 1. Okay. I did long division. Arkadeep, I did long division method. I did long, this is known as long division method. I just showed an illustration because you should always ask questions that how this comes out to be this. So I just gave an example that whatever power we have here, if we have R power 4 minus 1 divided by R minus 1, we will get R cube plus R square plus R plus 1. If we have R5 minus 1 divided by R minus 1, we will get R4 plus R cube plus R square plus R plus 1. You have to remember this. Okay. How we obtain is long division method, polynomial division. This is known as polynomial division. So we all know that अभी आपने देखा है कि the sum of first n terms of a geometric progression is A Rn minus 1 upon R minus 1. So, you know, if mod of R is greater than 1, okay, if absolute value of R is greater than 1, then S infinity will be, you know, not defined. What do you mean by S infinity? Sum of an infinite GP. Infinite GP का मतलब GP रुक ही नहीं रहा है. A1, A2, and they are adding and adding and adding. So there is no end. So if the absolute value of R is greater than 1, now I hope everybody knows what is an absolute value. If not, I will tell you. Suppose you have minus 2. Absolute value, it is 2. Absolute value of 2 is 2. So whenever you have a negative number, you convert into a positive number. That is what is meant by absolute value. Okay. So if the absolute value of R is greater than 1, the sum of infinite terms of a GP is not defined. But if absolute value of R is less than 1, then sum to infinite term is A upon 1 minus R. Please, it is very, very important formula. Note this down. This is the formula for sum of first n terms of a geometric progression. This is the formula for the sum of infinite GP if the GP is not stopping only when the absolute value of R is less than 1. That means R lies between minus 1 and 1. That is what I mean by this. if r is greater than 1 or r is less than -1, then the sum of an infinite GP is not defined. Okay, so this is the structure which is needed to solve questions on geometric progression. How to write the nth term, what is the common ratio, what is the sum of first n terms of a geometric progression, how do we calculate sum of an infinite GP if the absolute value of the common ratio is less than 1. That means if the absolute value of r is lying between -1 and 1. So the next type of progression is harmonic progression. Harmonic progression. So what is harmonic progression? So, is a progression is said to be in harmonic progression if the reciprocal progression, now this is very important, if the reciprocal progression is in AP. बस इसकी यही डेफिनेशन है. मतलब अगर टर्म्स को उल्टा करके रेसिप्रोकेट करके एपी बन रहा है तो हमारा गिवन प्रोग्रेशन एचपी होगा. एग्जाम्पल, इफ यू टेक 1, 1/2, 1/3, 1/4 एंड सो ऑन. सपोज ये आपका एक प्रोग्रेशन है. टेक द रेसिप्रोकल्स. Reciprocals means this is 1/1. So 1, this will become 2, this will become 3, this will become 4. This is an AP. इसीलिए ये क्या बन गया? Harmonic progression. So that is the definition of a harmonic progression. What is the definition of a harmonic progression? A progression is said to be in harmonic progression if the terms, when their reciprocals are taken, they become an arithmetic progression. That is the definition of harmonic progression. Harmonic progression is based on the definition of an arithmetic progression. There is no said formula to calculate the nth term of a harmonic progression or sum of first n terms of a harmonic progression. But questions related to harmonic progressions come in exam and they can be dealt with using the concept of arithmetic progressions only. Okay, so we are doing practice questions part 4. Okay, first question, consider a GP series whose first term is 1 and the common ratio is a positive integer r greater than 1. Okay, so we have a GP whose first term is 1 and the common ratio is r. So how does my GP look? 1, r, r square and so on. This is the situation of my GP. Okay, now consider an AP series whose first term is 1 and whose r plus 2th term coincide with the third term of the GP. Okay, so what is an AP? So AP is 1. Again, the first term is 1, but I don't know what is D. So I'll write 1 plus D, 1 plus 2D and so on. Okay, now let us read the line very, very carefully. The line which is going to help us to solve the question. AP whose r plus 2th term coincides with the third term of GP. So what are they saying? Third term of GP, which is equal to A r square. Okay, r square coincide with the r plus 2th term of AP. So what is an of an AP? A plus n minus 1D. So instead of n, we want r plus 2. So a r plus 2 is a plus r plus 2 minus 1D. Okay, so a r plus 2. Now what is a? 1. 1 plus r plus 1D. Now it is given that this r square should be equal to 1 plus r plus 1D. Okay, so r square minus 1 is equal to r plus 1D. Now this is a square minus b square. A minus b into a plus b is equal to r plus 1D. Okay, so okay, So what happens here? What is your D coming out to be? Your D is coming out to be R minus 1. So the common difference of the AP is, so you need to find D. And your D is coming out to be R minus 1. Is it clear how we solve the question? We could solve the question only with the knowledge of how to write the general term of a geometric progression and how to write general term of an arithmetic progression. Practice set 4, question number 5. If X, Y, Z are positive and are in HP, then we need to find out this thing. X minus Y upon Y minus Z. Now, what do you know about HP? You only know one thing about HP, that if terms are in HP, the reciprocal are in AP. Okay. So what is given? It is given that X, Y, Z are in HP. What does it mean? It implies that 1 upon X, 1 upon Y, 1 upon Z are in AP. What does it mean? It means second term minus first term should be equal to third term minus second term. Why? Because second term minus first term is common difference. And third term minus second term is also common difference. Common difference of an AP is same. So this is going to happen. So that means XY is, this is going to happen. Okay. So Y and Y get cancelled out. So X minus Y upon Y minus Z is equal to X upon Z. So option number C is the answer. So we could proceed with this question only by using the definition that terms are in HP if and only if the reciprocal terms are in AP. That is the only information which helps us to decode the problem and get a solution for it. This is a very good question. Question number 6. If the positive numbers x1, x2, xn are in AP, then we have to find out what is this. Okay. So whenever you have square roots in the denominator, okay, the first thing that should come to your mind is rationalization. I do not like square roots in the denominator, and you should also not like them. Okay. So they look very messy. So what do? So I multiply the first term with this. Okay. So I multiply with root x2 minus x1 in the numerator, and similarly in the denominator, I do the same thing. So look at the first term. The first term will be root x2 minus root x1, a plus b into a minus b. So that will be a square minus b square. So my first term is this. Okay. So let me use another color for this, the second one. Okay. Look at the second one. So for the second one, what you do? You multiply with root x3 minus root x2 in the numerator, and with same okay. So what you get? You get root x3 minus root x2. Again, a plus b into a minus b. So x3 minus x2. So there is a pattern. Okay. Similarly, if you look at the last term, okay, this should be equal to root xn minus root xn minus 1. And in the denominator, we'll have xn minus 1. Okay. Now look at all the denominators. This denominator, second term minus first term, x2 minus x1 should be equal to d. Look at this denominator, x3 minus x2. This should also be equal to d. Third term minus second term. Why? Because what is an arithmetic progression? There is a constant difference between consecutive term, current term minus the previous term. So again, last term, xn minus 1 equals to d. Okay. So now just observe what will happen. The first term will become root x2 minus root x1 upon d. The second will become root x3 minus root x1 upon d. And we will keep on going. And the last one will become root xn minus root xn minus 1 upon d. So we can take 1 upon d common, and we can have root x2 minus root x1 plus root x3. Okay, this is x2 minus root x2 plus root xn minus root xn minus 1. So now you can see what is going to happen. This x2 will be cancelled with this. And then if you see the next term after this, to have clarity, you will have root x4 minus root x3. So this will be cancelled. So all of them will keep on getting cancelled. Only this will remain. Root xn minus root x1. Okay. This will remain. But you see in my options, we do not have any. So again, we will rationalize. So root xn minus root x1 multiply by root xn plus root x1 divided by root xn plus root x1. Okay, that makes our life little bit easy. A minus b into a plus b, xn minus x1. And again, we have root xn plus root x1. So you can see that we have obtained the denominator. Let us see which option is correct. Okay. Now, if you look at xn, okay, what is xn? Xn is first term. So suppose the first term is x1. So first term plus n minus 1d. And what is x1? X1 is x1. So when I say xn minus x1, I will get n minus 1d. So here I should be getting n minus 1d divided by d root xn plus root x1. This d and d will cancel out. So we have n here. We want n minus 1. That means none of the above. Okay. So this is a very beautiful application of rationalization and then using the concept of common difference. Question number 7. If x is equal to 2 raised to the power 65 and y is equal to this, then, okay, so just look at y. Y equals to 2 raised to the power 64 plus 2 raised to the power 63 till 2 raised to the power 0. उल्टा लिख लेते हैं. 2 raised to the power 0 plus 2 raised to the power 63 plus 2 raised to the power 64. So ये ऐसा होगा. 2 raised to the power 0 plus 2 raised to the power 1 plus 2 raised to the power 2 till 2 raised to the power 64. 2 की पावर 0 से लेकर 64 तक जा रही है. हाउ मेनी टर्म्स? सबसे पहले तो टर्म्स काउंट करनी. हाउ मेनी टर्म्स? 0, 1, 2 से 64 तक काउंटिंग हो रही है. 65 टर्म्स. पहली गलती यहां पर ये होगी that students will count the number of terms to be 64. They will count from 1, but there is no counting from 1 here. The counting is from 0. So terms are 65. Now let us see what is y represented. 2 की power 0 is 1. 1 plus 2 plus 2 square plus 2, 64. So what is y? Y is the sum of first 65 terms of a GP whose first term is a equals to 1 and common ratio is 2. Please pay attention what is happening. आप देखिए सेकेंड टर्म को कैसे मिली मुझे. सेकेंड टर्म 1 को 2 से मल्टीप्लाई करा तो सेकेंड टर्म आ गई. फिर 2 को 2 से मल्टीप्लाई किया तो थर्ड टर्म आ गई. सो what is happening? I am multiplying consecutively by 2 to get the terms. So this is a geometric progression. कितनी है? How many terms are there? 65 terms. First term is 1, common ratio is 2. Okay. So what is the sum of n terms of a GP? हमने फॉर्मूला सीखा था और इसीलिए फॉर्मूला इंपॉर्टेंट है. यहां पर a क्या है? 1, r क्या है? 2, n क्या है? 65. So S65 equals to 1 2 पावर 65 माइनस 1 अपॉन 2 माइनस 1 और एस 65 है क्या y y एस 65 ही तो है फर्स्ट 65 टर्म्स ओके सो y इक्वल्स टू 2 रेज टू द पावर 65 माइनस 1 2 माइनस 1 क्या होता है 1 ओके और 2 रेज टू द पावर 65 है क्या x सो y इज इक्वल टू x माइनस 1 just see. So this is the formula for arithmetic mean. This is the formula for geometric mean. This is the formula for harmonic mean of n numbers. And this is the relationship which will help you to solve a lot of problems for your entrance examinations. Very, very handy. Question for you. Yeah, let's see. Let's look at question number 4. If A, B, C are positive real numbers. So whatever the formula for arithmetic mean, geometric mean, and harmonic mean I've given to you, those are for positive numbers only. Please add. So what is the least value of this? Okay. So if A, B, C are three numbers, the arithmetic mean is A plus B plus C upon 3. And the harmonic mean is 3 upon 1 upon A plus 1 upon B plus 1 upon C. अगर आपको याद होगा फॉर्मूला अरिथमेटिक मीन वाज a1 plus a2 till an upon n and harmonic mean was n upon 1 upon a1 plus 1 upon a2 till 1 upon an. So here we have three terms a, b and c. So we do am as a plus b plus c by 3 and hm as 3. Here is n is 3. 1 upon a plus 1 upon b plus 1 upon c. Now we know that the arithmetic mean is greater than or equal to harmonic mean. What does it mean? It means that a plus b plus c upon 3 is greater than or equal to 3 upon 1 upon a plus 1 upon b plus 1 upon c. So let us cross multiply this whole term. So a plus b plus c 1 upon a plus 1 upon b plus 1 upon c is greater than or equal to 9. So ये जो क्वांटिटी आपकी है this is the quantity that they are asking for and this quantity is greater than or equal to 9. That means this particular expression with either take value 9 or greater than it. That means the least value of this expression is 9. Option number A. So this is one of the applications of this arithmetic mean greater than or equal to harmonic mean. So you will be facing these kind of problems where you have to use this AM greater than or equal to GM greater than or equal to HM. Here the relationship between arithmetic mean and harmonic mean came into play.